Hello guys, I'm the Guide Knight and welcome to part 5 of my Godot tutorial. We are creating this endless runner game and this is our player. And let me just make sure that the collision shapes are not visible, or you can just go to the player and disable this, right? You can just make it invisible and there we go. We can see into the blue eyes of our player. All right, so last time what did we do? We created this endless pipe generation in one direction, only on the right. And on the left direction, we didn't do anything. There was also this very weird and annoying flicker with the background that we also want to fix right now. So let's see how far along we can go with this tutorial. Last episode was quite large, so I'm sorry for that. I'll try to make it shorter this time. So go to, first of all, make sure that your parallax background has like this ignore camera on. Actually, I'm not sure if this is needed or not, but I just wanted to make sure you have the same setting as me. And then go to the sprite and make sure it's not centered. Then you click on the parallax layer and then move it basically on the top left. Basically, it's in the top left of the viewport, like this is the camera, the purple thingy, and save. And this should now fix it. Let me see if it's seamless, the transition. If I run to the next slide, yeah, it looks like it's seamless. And this should be the fix for the parallax layer. I think you can also basically change it a little bit so that it's higher or lower, and this should work regardless. So there's a fix for that. Maybe there are also other options, but this is one of the easier fixes I found. So what else did we do? Let's go to the script and open the simple dynamic level that we created. First of all, let me get rid of this comment because it's a little bit annoying. And also this print statement, I don't really need to have the position all the time printed, even though it's helpful to know in which cell we are right now, because this position is like on the cell and not the X pixel position. So we would like to now also go to the left, right? So let's, if the position is on the left side of our current batch, so elif, we can actually just copy this because it's mostly the same, right? So if cell position is less than our current batch minus batch size, so we have gone one batch size to the left. In that case, the current x position will be the current x minus the batch size. Again, we go one batch size to the left. And I will get rid of this annoying empty spaces again. All right. And then what happens is we're moving one batch to the left. So our previous batch will be our current batch, and our current batch will jump one to the next batch. So because the next batch is always on the right, the current batch is where we are on the left, the previous batch is the left side. You can also call them like left, middle, and center if you prefer. I go with previous, current, and next. Maybe I'll rename them. Let me rename them. Like left batch, I can simply rename them by Control Shift F was the keyword. So I can replace it with left batch, replace O, no undo. This will be the current batch I actually like, and the right batch. So I first need to find it and then I need to replace it, right? So this is right batch. Alright, let me just run the game to see if it still works. It still works, there's nothing on the left, alright. So what needs to happen is our basically left batch will become the current batch will become the right batch, right? So let me change this. This, I'm actually gonna rename this, so like current batch will be, come on, will be my middle batch. Because consistency is always important, guys. So, right. So basically, we need to make sure that our right batch becomes the our middle batch becomes the right batch, right? So right batch is equal to our middle batch. Then our middle batch will be equal to our left batch. And then we need to generate a new left batch because we're going on the left this time. And this will be basically easy, just minus batch size, because we already adjusted the current X position here. And then we're gonna generate it from minus batch size till the current X. And we're not changing the Y position yet, so there's that. So let me just try and run it. Now I'll be able to run in both directions, right? And I have auto generation in both. But I would like to clean the tiles, right? I don't want to have tiles outside of my batch, and then I can make a bigger batch, and then I won't see that they're clean. But right now everything is small so that we can see and judge. All right, so what we need to do is at the beginning of each function, just go clean batch, and then clean the batch that is going to be deleted, right? If we're going right, the left batch, the leftmost batch is going to be deleted. So we can just clean the left batch. And if we're going left, the rightmost batch is going to be deleted, right? So we're just gonna clean the right batch. But if I run this, what happens? There is a problem because it says non-existent function size of base nil. So this means that base batch here is nil, right? And we can verify that size is an array function by going to the search help here, then array, and then I can basically control F, search for the size function, right? And there are like several matches. There is the resize, but I am looking only for size. Let me see where the size is. There should be a size somewhere. Ah yeah, there's this thing here, size. Returns the number of elements in the array. So our call to size is correct, but we are not passing anything to this to this function, right? The clean batch is getting nil. So the problem is that in our generate batch, we actually forgot to have a return statement, right? We need to return the batch that we are generating. And if you do this, it should look like that. Right now I am running endlessly in both directions and I'm not getting any garbage left, right? So regardless of how long I run, I won't be flooding my system. I won't be getting any frame drops. So that's nice, right? So, but this is a little bit boring, right? I mean, it's nice, but it's boring. So what we want to do is have a vertical and difference, like we want to go up and go down and so on. So we're gonna do this by the following algorithm, basically. Right now we have those pipes that are vertical. Don't mind the bad drawing, but this is like the X position we want to put the next pipe. And right now at each X position, this is X plus 1, at each X position we are putting a horizontal pipe, right? But if we want to like change it and put a vertical pipe that ascends, we can just put a pipe that is like this, from the left to the top, and then put several vertical pipes, and then put a pipe like this, that's from the bottom to the right. And then with the next X position, we can simply continue, right? And if we want to like descend, we can just do the same, right? So we can just put a pipe that goes down and put several vertical pipes, then this, and this will be the next X. So in this area here, we're only changing the Y position, right? We're only changing the Y position, and the X position is changed always by 1. So this is actually very convenient for us, and we can simply go to our generate batch here, and we can create a random variable, right? We can create a random variable that determines if we're gonna have a vertical ascended path, descending path, or a normal path. So I'm just gonna call it random, and it's gonna be in random range between 0 and 1. This will generate a floating point value that will be in the from 0.0 till 1, right? I don't think it's inclusive in the right side. Usually most functions are inclusive only on the left side, so probably it can be 0, but probably cannot be 1. Let me just check. Random range, any floating point value between from and to. It's not specified, but in our case, it doesn't really matter that much. So we will then do several statements, right? If random is less than 0.15, like 15% of this, like basically random is from 0 to 1, so it's basically 100%. So in around roughly 15% of our cases, we will generate ascending path, right? And for now, I'm just gonna leave it like that. And if random, so in the other cases, like it's not less than 15%, if it's less than 0.45%, so in about 30% or 31, about 30% actually of the cases, we're generating a descending path because we want our map to like be more downwards than upwards, because downwards is more fun, you can fly more. And in the other case, we'll just generate a normal batch, right? So we can just append this because it's easy. So first of all, let me go to my pipe function, add pipe. No, not here. What do I want to do? Ah, yeah, this start x. I'm gonna just call it start y. I'm just gonna call it start y, yes, but I will create a variable that I'm gonna call current y. Or maybe cy or current y. Current y. And it's gonna be, at first it's gonna be equal to our start y. So here I'm gonna use the current y, and I can make sure that this thing notes and returns how many changes are there in the y. So I can just say current y is gonna be like this, right? So in this case, current y does not change because we are only changing in the x direction. We are making basically a horizontal pipe. So there is no change in the vertical at all. So we can simply say in this simple case, current y changes by 0, so I'm not gonna change it at all. So I don't need a function here. And what does this function need actually, right? It needs if we are this place, we need the initial starting coordinate, right? So this has an x and a y, and then it will do whatever in any direction, maybe up or down, and then it will return the changed y position, right? Because the x position changes by 1, we can also return that if we do something more fancy, but right now we don't need it. So we can just say, okay, this is going to basically use the x position, the current y position, and I'm gonna pass in the batch because I would like to add to this batch anything that is being added inside this function, right? So I'm gonna create it right now. So let me just then create the functions, right? Function generate descending batch, pass, and function generate descending batch, also pass, right? For now. Okay, descending path. Descending batch, descending path, all the same. So in the generate ascending path, let me just first do this, and maybe we can comment this out for now with Control K. We can comment it in or comment it out. So we're just gonna have some ascending paths and test this, right? So I will then make sure that the batch appends this pipe, right? First of all, and for the ascending pipe, it's always this pipe. Sorry for the bad drawing, it's basically this. And the name of this pipe, if I go to the tile map, is curve left top, like left top, and the others are called similarly. So I can just say, I can copy this, and I'll say curve left top, right? This is the, let me just go and y, call it y. Okay, at the x position, and the y position, I'm going to add a curve left top. And then I'm going to change my y position, right? So y is equal y minus 1, because we are going up, right? And if you remember, y is lower the more up you go, so it's gonna be decreased. So y minus 1, or I'm just gonna use the shorthand writing of this, is equal minus equal 1, right? Then I would like to know how many pipes I want to have, right? I'm gonna just create another random variable that I'm just gonna go random range between 0 and 2. And I'm actually going to... so this means that I can create 0 or 1, but I actually want to use the other function of floor, right? We used floor here. If you remember, it rounds it down. Now I want to round it up. So I'm going to use the opposite function of floor. It's called ceiling or ceil. And I'm going to do this. So this gives me a function that's probably mostly between 0 and 2, with a very low probability of being 0, almost none, and mostly to be 1 or 2, right? So then I can do a for loop. And I can just say, okay, for I in range between 1 and random. So I don't want to make I want to make sure I have at least 1, right? I don't want to have like 0. I can even have like, okay, 0. I don't know. It's fun. So then I will just add a vertical pipe, right? And the vertical pipe is called vertical bolt. So I'm just gonna call vertical bolt. And here for the y, I'm gonna also decrement it by exactly 1. And in the end, I'm just going to add the same, but curve, it's gonna be probably bottom and then gonna be right? Nah. A little bit curve bottom right. So this is going to be my thing, and then I can return the y, right? I'm not at the final point. I'm actually doing this, so actually I should decrement it once more. I'm not sure. Okay, this is this and this. Okay, I'm decrementing it here at the end. Okay, so this should be actually covering the final decrement for this one. So it could work. Let me check. Okay, so now we have this, right? And it does work. And it can generate probably various sizes, but you see that it does not really continue the next batch from the previous one. So let me... maybe we're gonna do the descending path in the next section, and then we're probably gonna also do the stopper on the left, because we don't want to clean up the things. It's gonna be a little bit more tricky, so we're just gonna not do that. So okay, so the current y, why does not it change it? Okay, I'm using the current y, Okay, so it doesn't actually change it because we are not changing it, right? It's a little bit of a no-brainer, but why are we not changing it? Is that this thing is called multiple times from outside of, from different places, right? It's called from the ready function, it's called then from the player location, mostly from here. But here it is passing the current y, right? And the current y is already a global variable for the script, right? It's accessible globally for the script. And we are defining a new current y here. So we actually don't need to do that, right? We can just okay, this is like the start x and end x, and this is the current y, and we actually don't need to pass in the current y at all. We can just use the current y and adjust it, right? It's a little bit maybe not the best option, but otherwise, I mean, Where do we change? Okay, here we change the current x and inside the function. It's maybe a little bit messy, but this should do the trick. So if you now play it, it will generate a level where it always, and on the left side it's just broken basically. So we're gonna fix that in the next episode. As I mentioned, I don't want to make them the episodes a lot longer than 20 minutes. And if you just wanna like try with a larger batch size, you can do batch size of 10, and then you have stuff like this. It's a little bit nicer right now, right? And then you can yeah, you can jump, but it doesn't fix it because we can drop below the pipe, and we have to fix it on the next episode. But this is already pretty nice, guys. Hope you liked it, and if you did, give me a thumbs up, and that would be to support me actually greatly. And I would like to thank you all for subscribing and watching my videos. That is really nice. I'm super happy every time I see a new subscriber and a new like, and also a comment. So thank you for that, guys. Stay awesome, as I know you are, and you know you are. If you don't know, you are awesome, guys. You are awesome. I'm telling you this. So be happy, be cool, and see you next time. Bye bye.